Hi, everyone. Thanks again for coming to our webinar. Thanks for tuning in for the second installment of our series. So last week we gave a little introduction, and this week what we're going to be talking about is Internet of Things IoT data modeling with open standards. So as you know, SensorThings is an OGC open standard. SensorUp builds an implementation of it, and we're going to give you a little bit of an introduction to or a talk about data modeling and open standards. Once again, Dr. Steve Liang of the University of Calgary's Department of Geomatics is going to be giving the talk. And I'm sure that you all heard this last time, but just for anybody who's new, Steve's expertise is in geosensor web specifically, and he's been working throughout his career on this topic and is a recognized expert in the field. So you're going to be getting a very well-placed talk today. So the series, this again is number 2. It's running every Thursday at 1 p.m. Eastern. It's going to run for 2 more Thursdays after this one. Next time we're going to talk about connecting and managing sensors, and then the last Thursday will be about querying and analytics. So just a little bit about logistics. If you want to ask us questions, we'd absolutely love to have them, and we will answer them at the end. Just move your mouse down to the bottom and you'll see Q&A. Click on that and you can ask us questions through there. And that is it for now, so I'm going to hand it over to Steve to give you the talk.
Hello, everyone. Thanks for coming back. And for the American friends, hope you have a great Thanksgiving. And I did something stupid, scheduled time, this webinar during your Thanksgiving. But anyways, okay. So today we're going to talk about the SensorThings Data Model. So the agenda. So first, we'll talk about data model. And for those who love UMLs as a standard, we have something official and formal, show you the UML diagram and the steps involved of IoT data modeling, and use some use cases and to test or validate our data model. And finally, today, we're going to launch our OGC SensorThings Playground, which is an interactive tutorial, allow you to learn sensor things using a very friendly online interactive tutorial. Okay, so here we go. Something about me. Well, I'm involved in many standard organizations and efforts, and that's our passion, which is the open IoT, allow the different thing networks able to interoperate with each other. We're sick of looking at the silos and then resources wasted because of the people are building silo. And SensorUp is a startup company from University of Calgary, and we are recognized as a world leader in OGC sensor web in IoT. And we are leading several international IoT standard development efforts, including OGC and ITUT. Actually, the interesting thing is this week, the past week was the OGC technical committee meeting, and right now is the ITUT study group 11 meeting. So yeah, my days and nights are very busy because of meetings. Anyways, and SensorUp developed world's first OGC SensorThings API implementation. And we are also proud member of Eclipse Open Source Foundation and OGC. Some news update to you guys. Congrats, actually, as of last night in Sydney, OGC Technical Committee approved an electronic vote to approve release of OGC SensorThings API as an OGC adopted standard. That means the vote will start in a couple days, and then after a couple weeks, when the vote closes, and we might, very likely, 90%, I hope, 99%, we will become an official OGC standard. So SensorThings will be a standard very, very soon. That's good news. And thanks for everybody contribute to this amazing standard. Okay, so today we'll talk about data model. For any OGC standards, or actually, if you want to have exchange data, open data, and over the web, you need to have 2 components. So part 1, you need to have a standard data model so that the 2 components can understand each other, the applications and the web server. Part 2, you need the interface to define how are you going to exchange, how can you query, how can you analyze through interfaces. And so that's 2 parts. So today we talk about standard data model. And next time, we'll dig in more into the interfaces. SensorThings Data Model is based on ISO 19156, so which is of observation and measurement. It's a conceptual model, or you can call it ontology. And because we're based on this model, so actually we can accommodate a lot of different use cases. And today I'm going to show you some use cases. So before we dive into data model, and let's introduce what's observation and measurement. So the whole thing on your screen is an observation, circled by this blue circle. So the core is the result. If you look at the results, and for example, every observation has a result. And however, the relevant information of the observation are also very, very important. If you look at your left-hand side, there's observed property. When you have an observation, let's say you have an IoT device, you are observing some phenomenon. And the phenomenon you are observing is very, very important. It's a contextual information. In this case, for example, it's the wind speed. And also the procedure or the sensor which collect the observation is also very important, because if you want to use that observation, that's a very critical metadata. So in this case, it's a Davis wind speed sensor. And also the target of the observation, in order to use the observation, the target is also very important. So that concept is called the feature of interest. In this case, if you look at the figure, the wind speed sensor is mounted on top of a roof. So the air above that roof actually is the feature of interest of that observation. Yeah. And every observation, you have a result. We know that. The unit of measurement, UOM, is critical. If you don't know UOM, you cannot use the data. It could be, for example, for temperature, Celsius or Fahrenheit. It's very important to know it's Celsius or Fahrenheit. So your UOM is also very important. Finally, the time. You need to know when it's collected. So that's a phenomenon time. And altogether, it becomes an observation. So for any IoT applications, all this information actually are critical. But a lot of applications or the platforms, they focus on the value, which is the result, 23, and the time. But a lot of information are missing. So maybe for a very specific, the early application, that might be useful. But in the future, the contextual information, the location information, the temporal information, and the metadata, observed property and procedure or sensor, they are critical if you really want to develop a serious application. So here's a UML, and I couldn't find my mouse here. Anyway, okay. So let's look at the top left. That's the center of this data model. That's a fin. So the first step when you do a data modeling for your IoT application is, what is your fin? And in this data model, one fin can have multiple data streams, 0 to many data streams. And data streams, if you go to the right, one data stream have 0 to many observations. For example, I have a Nest thermostat at home, and it collects temperature observations. So we have a temperature data streams. So for that data streams, you have many, many observations collected in space and time. And let's focus on the right-hand side, observation. Each observation has a feature of interest. That's the target of this observation. And let's look at this example of a thermostat. And every temperature observation, the feature of interest, which is a target of the observation, is my house. So that's a feature of interest. And feature of interest has location. Like my house has a location. That's important. And let's go back to the center, the data streams, and go up, observed property. Observed property is to describe the data stream. So what phenomenon this data stream is describing, is observing. So that's observed property. Thermostat example, that could be a temperature, air temperature of the house. And if you go to the top left, that's a sensor, or in the O&M model, it's called procedure. Sensor is a special type of procedure. And this is a metadata. It tells you, okay, so you collect a whole bunch of observations, and which sensor model you are using. It tells you the accuracy of the sensor, the calibration curve of the sensor, the owner of the sensor, and any relevant information that is useful in order to make the observation useful. Okay, let's go back to top bottom. So fin. Each fin in this data model has 0 to many locations. I think it makes sense, right? Everything has a location. So, but why in this data model it has many locations? This is very, very innovative in this spec, because every fin, it has a location, and the location can have different representation. For example, let's say we have a thermostat. Okay, so in a geometrical space, geometry, the thermostat locates in a geometrical space. However, the thermostat, let's say we put the thermostat on campus, and it can exist, the location of the thermostat could be a room. And a room, you can describe this room location in different location encodings and location models. But in summary, this extension or this model allow you to describe your thing both in indoor and in outdoor, or in 2D model or in 3D model. And it's very, very extensible, so that's great. And of course, when some of the things, they move so that they have historical locations. So I just go over the data model and describe each one of them. So let's use some use cases. So these are the steps of data modeling. First one, what is the thing in your application? So identify the thing, and then identify the phenomena. That means the observed property. So what's the observed property that your thing is observing? If you have an RFID reader, so what's the observed property of RFID reader? If you have a camera, what's the observed property? And then what sensor you use to collect these observations? That's the third step. And finally, the target of your observation. I have a camera, and what is the target of my camera? I have a baby cam, so target is my baby. Yeah, makes sense? Okay, let's look at some use cases. First, definition of a thing. A thing, this is from ITUT, United Nations Standard Body, an object of the physical world. So it could be a physical thing. Our standard is able to accommodate physical thing, a table, a chair, or a virtual thing. It could be a derived thing from a physical thing. Or sometimes, if you are a device maker, before you ship or even you make your device, these things are virtual things. So in many cases, you will have those things in the virtual world in a SensorThings API first. And when you make them, and then you have a physical thing, and then you connect them together. This is a more complicated use case, but just to let you know, SensorThings API accommodate all these scenarios. Okay, use cases. So let's say from a device maker's perspective, this is a Wi-Fi connected scale. So if I make this scale, okay, how can I use SensorThings API as my IoT device platform? So what's the thing? First step, what is the thing? It is a Wi-Fi scale. From my perspective, I'm a device maker, so my thing is a Wi-Fi scale. And put it, so location of the scale, the location of scale is my master bath. So that's the location. And the scale actually have more than 2 sensors, but let's say you have 2 sensors. And observing, so what's the observed property that those sensors are observing? The first one, actually the scale can observe my heart rate. So the first one, heart rate. So the first data stream is my heart rate data stream. The second one is the weight. So the second data stream is the weight data stream. And of course, each data stream uses a sensor to observe, like heart rate sensor or the scale. And for each observation, it has a feature of interest. So think about it, how many people are using a scale at home? In my house, we have 3, Steve, Lynn, and Noah. So the feature of interest, we have 3 different features of interest. So when someone step on a scale, it collects an observation. In this case, the feature of interest is very, very important. So you can have a different target, right? So Steve, Lin, and Noah. So from a device maker's perspective, this is how you use this to model. But how about you are a health analytics providers and you want to use a IoT platform, connected health, right? Hot topic. So from a health analytics provider's perspective, they want to integrate as many sensors as possible. Makes sense, right? Your sleeping time, your heartbeat, your weight, your breathing rate. So in this case, I want to integrate as many sensors as possible. So how to use SensorThings Data Model to model my application? Here we go. Let's say I'm a health analytics provider. So the thing, what is the thing? The thing is the person. I want to analyze the health of the person. So the thing is Steve. At the location of the Steve, point collected by GPS, for example, and from a GPS sensor. So what are the observed property or data streams of this? The first one, let's say I have a smart shirt. I want to integrate a smart shirt into this application. So I have heart rate, the first observed property, heart rate. The second one is weight. So I want to know Steve's weight. So these two. Of course, there is a sensor match each data stream. So hexoskin can be the heart rate sensor. The Wi-Fi scale can be the weight sensor. And if you go to the bottom right, that's the feature of interest. And if you want to go more detail, Steve's heart can be the feature of interest of the hexoskin. And my body weight, so that my body is the target of the Wi-Fi scale, so feature of interest. So in this case, if you are a health analytics provider, this is sensor agnostic. No matter how your application evolve, you can change your sensor provider. Because actually, you know what? You can have today, the person can use hexoskin to collect heart rate, but tomorrow they can use something different to collect their heart rate data stream. But it's the same data stream. And for your application, what you care is the data stream and its observation, rather than which sensor to collect those data stream. Of course, in order to use them correctly, more accurately, you do need to know the sensor. But what you care in this case is data stream. So show you the other example, which is a very different use case. However, our data model works. What if your thing is a traffic camera? This is a very different use case, and it works too. So that's a great thing about following standard. So let's say my thing is a traffic camera. So that's a traffic cam. The location, I mount a traffic camera on top of a light post. So that's a location. So it's not just a dot on the earth, right? It has meaning. It's a light post, has attributes and location. And of course, the sensor is the traffic cam. And then the observed property. Actually, you can derive a lot of observed property. You can derive a lot of information from the traffic cam. The first one could be a queue length. That's what I learned from my colleagues doing transportation, right? Everybody wants to know, so how long is the queue for an exit? So they can estimate or control the light proactively. So for the first data stream, observed property is the queue length. So what is the feature of interest for that queue length? The highway? Actually, no. It's the exit. You want to know the queue length of the exit. So the feature of interest is an exit. And the second one, data stream, observed property, is the raw image. Okay, so you have a camera looking at the highway. So what's the feature of interest? The target feature of interest is a section of highway number 2, for example. So this data model works. In this case, I want you to pay attention to the bottom here. The location and the feature of interest, they are different. This is a remote sensing use case. And because we are based on ISO, OGC, ONM, so we can handle these two together. And actually, we have more and more different use cases. And we can put not only remote sensing, we can put remote sensor and in-situ sensor in the same system together, and they work nicely. So again, no matter how your application evolve, this will work. Conclusion, What is your thing depends on what's your use case. And SensorThings API support multiple views to model your IoT applications. It's flexible. I think I just demonstrate it is flexible and future-proof. That means your IoT investment can evolve with your business. Today, you have one sensor, one type. Tomorrow, let's say you grow like very, very fast. You have 100 different type of sensor, including both a drone, a traffic camera, and a thermostat, and a Wi-Fi scale. And you still can use the same SensorThings service for your application. So this is to protect your investment of time and resources. Okay, so today we are very happy, excited, I would say, to launch the SensorThings Playground, which is an interactive tutorial to show you how to use SensorThings. So the link is pg.playground.sensorup.com. I encourage you to go there and play. And if you want to test OGC SensorThings, like how does it work with the real sensor? And we have two links below. So it shows you a working OGC SensorThings service and allow you to play. And we need those. We will use those links next week to show you the API. So I want to show you how the playground works. Okay, playground pg.sensorup.com. Okay. So I encourage you to go register. I'm registered, so I just log in. Without logging, I'm here. So the first page I want you to pay attention to this green box. So allow you to start a guided setup. So that's the first place you should go. And for developers, we have some more information for developers at the bottom. So if you are interested in developing SensorThings application, and pay attention to the bottom. In this case, which is every user will have a access token. So you can access your own thing, and others cannot access your thing. And you need to use the header of this, STP access token. By the way, this is a playground, not the archive. As a result, we will remove the readings every once in a while, so that you don't need to worry about you put any messy readings into it. It's a playground. Feel free to play. But also it also means don't put anything or any observation mission critical using this, right? If you have a real application, you need a proper hosting and a proper storage, please let us know. And we're very, very happy to work with you. Okay, so let's start the setup. Click the button, and then there are the guided the steps. So first thing is create a thing. So identify your thing. So my thermometer, for example, let's say in this case is thermometer. And here, I want to show you that you can change your thermometer into my thermostat. Okay, and you will see on your right-hand side, API request update automatically. So this is a one example. So show you how to do using a more user-friendly interface, and the right-hand side show you what's the technology behind the scene over here. So that's my thermostat. Click, and then location. So define your location, and in this case, you can use my location, and API request changes as well. And next, define your observed property. A thermostat, let's say I have a temperature sensor in the thermostat. So the observed property is air temperature. So it's air temperature. And actually, in order to help you to search for the appropriate observed property, we have the autocomplete here. For example, say water, and these are some example observed property for relates to water. But in this case, it's air temperature. Or let's say quality. No result, air quality. Not air quality. It's not like carbon monoxide, for example. Okay. In this case, air temperature, and it automatically fill these for you. And these are, and right hand side are the code. Next. So what's the sensor? The sensor for temperature is a thermometer in this case. So if yours different, you fill in your own. Next. After you know your location, you observe property and sensor, and you can create the data stream. And one thing very important is unit of measurement. In this case is degrees Celsius. Okay, and next, review. And we have collected this information, fill them in. And if you're a curious developer, these are the JSON requests. And let's say I complete. And you will see the interaction between our client, your browser, and with our backend server happening. So this is a way for you to know really, okay, what's the interaction between the client and the server? So interactive way to learn SensorThings. I don't know, what do you think? I think that's cool. I love it. By the way, Joseph, very good job. Okay, finally, we create this, and then you can adding observation to the data stream. So go to the next page, and here are the information you just created, and they are in SensorThings already. And then I can add an observation. So this is a request for observation. Let me add an observation. It's in it. And let me add, say, 18 observation. It shows it. Okay, and we have table view as well. Okay, but I want to show you something more. It's a playground, and this is an interoperable open standard. So I want to show you, it's not only, you can not only do it in the system, you can do it outside, so interoperate with our service. So you can get all the necessary information, how to interact with our server from here. And right now, I'm going to show you an example. So for example, the server address of this playground, the SensorThings, the backend server, is this. That's the host, which is, you can find the host address here. And that's the URL. So that's the URL, which is here. And if you want to post to observation, here's the address to that observation. And we will talk about details next week. This is the interface. So that's the observation. And in this case, I just created, so the ID is 130870. So let me change to this. And let me do this. So copy this request and paste it here. And actually, I don't even need phenomenal time. I'll tell you why. It's a technique to save the power and bandwidth. In this case, the spec require, this is a mandatory header, accept encoding is application JSON. And in order to protect you, we have this access control. So put your access token here. And this is real demo. Okay, let me send application. Let me send the request. Send. Okay, so it returns some request, return a success. So let me refresh this page, and hopefully there will be a new observation added. Yeah, see? A new observation has been added into this system through a third-party client. So think about this. By the way, this is Postman, very user-friendly HTTP client you can use. And it could be a sensor as well. Could be your Arduino, could be your fridge, could be anything. So this just to show you that we complete this workflow in the system, and then, now this one, outside of the system as well. Okay. So hopefully enjoy it, and please give it a try. And after you try, what's next? You click here. We'll put more information in the future, but right now, we just post if you happen to have an Arduino, here's the code. How to connect your Arduino to SensorThings API, to our playground. So hopefully you enjoy it, and then, yeah, you find it's useful and educational. So that's today's webinar. Hopefully it's useful, and it's time for questions. So Q&A question. The first question, can you provide any literature source for IoT, semantics, and geontology? That's a very big question. You know what? I will write a blog about it. And so come back and check our blog, and I'll write some literature, the sources for you to know the ontology and the work regarding the IoT. Sounds good? And the next question. Are observed properties standardized? Is there URL definition what really identifies them? Is there any enforcement that observed properties don't end up with duplicate or ambiguous definitions? Great questions, and I'm pretty sure you know you have some deep knowledge in sensors and or IoT. Okay, first of all, observed properties actually is like an ontology. So if we're looking at standard observed property, actually normally you need to look into the domain. In the ocean science domain, there is an initiative called IOOS, and it provides a list, a taxonomy or ontology of the observed properties. So in that community, somehow, yes, at least you have a source you can use. And once you have a recognized source you can use, and then the definition will be available. So the URL, you can point to something. For example, in our playground, we point to the IOOS. So the definition really identifies them, and it's resolvable. That means when you click that URL, it gets a definition. So is there any enforcement that observed property don't end up with duplicate or ambiguous definition? So it's really, we need a community to have a mutually agreed ontology, and to that day, and it won't be ambiguous. So we start to see some very, very good initiative, right? In the ocean community, great work over there, Luis Bermudez and Noah. And then in health communities, yes, they do have the ontologies. In IoT, the commercial devices, man, it's messy. So we have some plans, SensorUp, we have some plans, try to help to make it more not so ambiguous. So please stay tuned. Next question. Is there any standard mechanism to communicate notifications from the server side back to sensor? Oh, great question. The answer is yes, and we will talk about it in 2 weeks. So in SensorThings API, we have a MQTT extension. So allow the server, actually not only server, the server and device application, they can use the push notification to communicate with each other. So it's very, very efficient and very, very real-time friendly. So we will demonstrate that in 2 weeks. And actually, we also have a continuous query engine. So not only push the observation to you, we can also filter those observations on the server side for you. So you only receive the information interests you when you need them. So stay tuned, come back. Next one. Is it possible to use this IoT spec for citizen sensing application based on image capture, for example, collect sightings for birds in the neighborhood? Great question. The answer is yes. And actually, we have examples for citizen sensing as well as image capture. And it covers bird, but we do more than birds. It's a generic biodiversity app. So we have 2 citizen sensing applications. One is for groundwater level. The other one is for generic biodiversity. So the answer is yes, and feel free to email us and for more information. We would love to work with you or answer your question. Okay, next question. Location feature information should be retrieved connected to standard feature names already contained within GIS database. How can this be accommodated? We have some expert in our audience. Okay, yes, how can this accommodate it? Actually, we support that. We just didn't show you today. In the SensorUp implementation, we have an extension. We are able to connect to an existing GIS infrastructure, for example, like a database or even OpenStreetMap, so that when you choose a location, you are not putting or choose just a latitude and longitude. You choose a feature. And so this needs some connection between our SensorThings API implementation and a backend GIS database server. So actually, this is also a great benefit or advantage of adopting SensorThings API because it works with GIS database very, very nicely or seamlessly. It could be a WFS, it could be an OpenStreetMap database. And in our case, we connect to PostGIS as well as OpenStreet database. So it depends what's the GIS database you are using. And by using this, for the organizations like the municipalities who already have GIS infrastructure, you really save a lot of time and effort for training, and you easy to maintain your database because it's one consistent source rather than the IoT has one database for locations and your GIS infrastructure has a separate one. And this is, and I think you found it in our design, right? Our design actually accommodate that. Feel free to ask us for more about implementation, and or we can even arrange a demo for you. Next questions. Are the tokens just private, or is there any public tokens so one can have access to other sensor data? In our case, this is our own implementation, right? But it definitely you can use OAuth, for example, or even you have to go more generic. For example, in Canada, we have a CAF, Canadian Access Federation, something like that. So the third-party provider allow you to do those access control. Yes, so answer is yes. But in our playground, it's our own access token. But if you have something more complicated, enterprise solutions, and you can have something on top of it. By the way, not only the token, you can have an additional security layer on top of SensorThings API to control the access level, and then as well as the protect the security. Next one. This is great. We have many questions. The question is, when a sensor has built-in GPS, is this considered as a separate data stream? If so, how does this get into location model? This is a great question. And first one, it depends on use case, and we accommodate both of them. The first one, if your application need to treat your location as an observation, I will say it again. If you need to treat your location as an observation, and it should be a separate data stream. Oh, but there's something interesting. A location, for example, 2D, let's say 2D example, actually it has two results, latitude and longitude. But in our data stream, it's only one result. So how can we accommodate that? And in SensorThings API, there's an extension, which is not the core, but if you go to the spec documentation, the document, it has an extension. It's called multi-data stream. And this is designed specifically for this kind of use case. So for GPS or weather stations. So it's one sensor, but multiple data streams. And these data streams, they are relevant or they depend on each other. So that's multi-data stream extension. So in that case, you can use this to support. But in most of the cases, if you don't need to treat your location as an observation, you treat them as the location. And you can simply just change your location of the thing. So this becomes a very efficient model. And so in this case, the location, when the sensor changes the location, it updates the location in the SensorThings API, as well as update the observation whenever there's a new observation coming in. So this is very efficient because in many cases, applications only want to see the things, the location, and we only want to see the observations when we need to. Okay, so this is very efficient. And also, it works very nicely with the MQTT notification. And this actually it is one issue for SOS, actually. For SOS OGC sensor observation service, it's the location model is a little bit difficult for the client to figure out what's the real location of that sensor or the thing or feature of interest. They are just a little bit ambiguous. And we fix that and make it more developer friendly. Hopefully, it's a long answer, but it's a complicated question, yeah? So hopefully I answer you, but more to come in the future. Okay, one more question. Would an autonomous network of homogeneous or heterogeneous, different kind of sensors, okay, be a new type of entity? Does the data model allow for this? This is a complicated question, yeah? Would the autonomous network of homogeneous or different type of sensor be a new type of entity? Ah, got it. Yes, when you have a network of sensors, okay, so I assume this question is, when you have a network of sensors, what is your thing? It, again, depends on application. If all these sensors, collectively, it's one sensing system, and if this way to model it makes sense for your application, yes, it's a thing. If not, every individual sensor network can be a thing. And since you talk about sensor networks, and so you might wonder about the power constraints. So in this case, when you do the data model, you also need to consider your power constraints. And what is your gateway? And what is your power constraints? How often your gateway wake up to send the information to the SensorThings? But in summary, we consider all that, and the data model allow for that. So the next question, thinking about UAV, does UAV fit into this model? The answer is yes. And actually, the roaming sensors, right? Yes, it fits very nicely. Actually, we have one project doing UAV right now using SensorThings API. Hopefully, I would say we just submit a proposal. Hopefully, we'll get the project. But it fit. A UAV is a remote sensor. For example, if a UAV, the thing's a UAV, the location is moving, so location changes, and then you have data streams. Data streams have two types. One type is the flight data, right? Whatever onboard sensor on your UAV for your flight control. And the other type of sensor is the payload, is the camera, right? And you have your sensor ML to tell you the camera information, and you have the observations of the raw images. So it works. Okay. Okay, final question, okay? Okay, we don't have time now, but great, you have so many questions, and they are all great questions. So final question, how does this spec work with other OGC specs? How to achieve interoperability? The answer is it works very, very nicely with other OGC specs. We tested, we have implementations, actually. We're not just saying, oh, the model works. No, the implementation works. We show it, we demonstrate it, we prove it. So SensorThings can become a OGC SOS very, very easily. And maybe next time I can show you a link. You can try it because they're both based on OAM. The location model, actually, it's just like a previous question. The location can connect to a WFS, Web Feature Service. It could also use something like the latest spec standard candidate. It's called DGGS, or could be an indoor GML. It could be a moving feature. And in our design, we consider all of them, and it plays very, very nicely with other OGC spec. And yeah, we might have, I think we will have a webinar just to talk about this. So how SensorThings work with other specs. And it really makes SensorThings API a much more powerful because we are able to leverage the 20 years of R&D of OGC and comparing to other platforms, right? And they start everything from scratch. And there are many, many different use cases. Actually, you know what? The 20 years of experience means something. Okay. Thank you all for all the questions and for participating in today's webinar. And we will come back next week. And please come back again. And in the meantime, please try the playground. And any questions, we would love to hear from you. Any feedback, we would love to hear from you. And just let us know. Thank you very much. And have a nice week and weekend. Bye, everyone.